To test h sub 0 where mu is equal to 100 versus h sub 1 where mu does not equal 100, a simple random sample of size n equals 17 is obtained from a population that is known to be normally distributed. If x bar equals 104.9 and s equals 9.2, compute the test statistic. So now what we're going to do is use t-test. We're going to use t-test. So we're going to do stat and go over to test. And the reason we're not using z-test is notice it asks for the population standard deviation. And again, we don't know that. And that's how we know we're on the wrong test. So if we go to t-test, mu sub 0 is going to be, I'll write down what I'm typing in. So our input is stats. mu sub 0 matches with what's in our null, so 100. X bar is 104.9. Sx is our S, which is 9.2. N is 17. And mu is going to be equal to mu naught. So let's type in our information. So we have 100, 104.9, 9.2, 17, and then not equal to. And then we're going to press calculate. So same idea, so t is going to be our test statistic, and then p is our p-value. So same idea, so t is our test statistic. So this is going to be 2.196001909. So this is our test statistic, and P is 0.043179747, so that is our p-value. And the rest of that is just values that we input into the calculator. So be asked, if the researcher decides to test this hypothesis at the alpha equals 0.01 level of significance, determine the critical values, and draw a t-distribution that depicts the critical region. Well, our alternative is not equal to, so just like before, we have two critical regions. So our critical regions here. And that value is split between the two critical regions. So if we take 0.01 and divide it by 2, we have 0.005 in each of those tails, and if I do 1 minus 0.01, we have 0.99 in the middle. So these values here are negative t sub alpha over 2 and t sub alpha over 2. So we're working with a t-distribution, so I can't just simply use the easy values that we have from the table. I have to use the t-distribution table. So I need to determine my degrees of freedom. So remember that's n minus 1. So that's going to be 17 minus 1, which is 16. And then the area in the right tail. So in this case, the area in the right tail is 0.005. So then we use my table to look up that value. So 0.005 and then 16 degrees of freedom, we get 2.921. So that gives us this one. So 2.921, and then by symmetry, this one is negative 2.921. So have to use our table there to find those values. So we now want to know if the researcher will reject the null hypothesis. So we're going to compare our test statistic there with those values. So where does 2.196 fall, or 2.20? So 2.20 falls roughly somewhere about here, right? So, no, since our test statistic does not fall in the critical region. Right, so again, same idea as with proportion, so that it, so we also could say no, because the test statistic is between the critical values. So since we do not reject, that means that there's insufficient evidence to conclude the alternative at the alpha equals 0.01 level of significance.